We are discussing about GATE 1996 ECE paper, and this is one more question related to electronics. An N-channel silicon with energy gap of 1.1 electron volts MOSFET was fabricated using N plus polysilicon gates, and the threshold voltage was found to be 1 volt. Now, if the gate is changed to P plus polysilicon, other things remain the same. The new threshold voltage should be A minus 0.1 volts, B 0 volts, C 1 volt, D 2.1 volts. So MOSFET is fabricating N-channel MOSFET. N-channel MOSFET implies nothing but always it should be fabricated in P-type substrate. So let us assume we are going with, this is a MOSFET diagram. So N-channel implies nothing but it will be fabricated under P-type substrate, and into that one 2N plus regions are diffuse. One is act as source, the other is act as drain. Above that one we will go for the silicon dioxide layer. This is silicon dioxide layer. This is also called as thin oxide or gate oxide. Gate oxide. Thin oxide or gate oxide. So for this one it is called as SiO2 layer. And next above that one we are going with a gate, and the gate is made up of N plus polysilicon gate. N plus poly. So by that time what we are going with is nothing but the threshold voltage is given as 1 volt. So whenever it is N plus poly, at that time we can think in this way: N plus poly, N plus is nothing but N type. N type is nothing but it is represented as in this way. The general representation of N type semiconductor is nothing but it will be a positive ion followed by a electron. So whenever electron leaves, at that time it will become positively charged ion. Simply N-type semiconductor, whether it is N-type heavily doped or lightly doped, N-type semiconductor is electrically neutral. Electrically neutral is represented with positive ion along with a electron, positive ion along with a electron. Like this here also you will get positive ion along with a electron, positive ion along with a electron. But whenever you are applying positive voltage at gate, at that time all these electrons from this one are going to be, all the electrons from these ions are attracted towards that positive voltage, gate positive voltage for N plus poly. Okay, for N plus poly, these the electrons from this nearby silicon dioxide region, the electrons are moving towards gate side, so that they are moving away from the SiO2 layer, such that positive ions are going to be gets created. So the diagram is going to be now looks like this one. This is N plus poly, and where you are going with positive ions are going to be placed near the silicon dioxide. This is what silicon dioxide region, and after that one this is what the P-type substrate, N plus N plus. So this side you will get the positive ions with electrons. So by that time whatever the voltage you are applying, that is positive voltage, along with this is extra positive charge created, extra positive charge, that is positive ions. These are going to be aiding to the voltage applied, so that now you are getting the positive voltage along with some extra positive charge. So that is going to be giving the negative electrons, that is this positive charge are attracting the electrons from this one. So electrons are going to be attracted over here, and a channel is going to be formed. Channel is formed. So if you are using N plus poly gate, at that time by using less positive voltage you can create a channel, because not only the positive voltage, because of positive voltage you are going to be getting a depletion region which consisting of positive ions near the silicon dioxide region. in the gate material is going to be taking place. This extra positive charge along with the actual positive voltage you are applying, it is going to be attracting the negative charge carriers from the p-type substrate, which are minority carriers. So they will be accumulated near the SiO2 layer, because SiO2 layer act as insulator. So they cannot come into the gate side, they will simply accumulate nearby this SiO2 region. So it will be forming a channel. So if you use N plus poly at that time, for small threshold voltages itself, for small gate voltage itself, channel will be created. Let us assume if you are going with P plus poly, if you are going with P plus poly at that time, P plus poly is going to be consisting of, okay, I will write over here, P plus poly. P plus is nothing but p-type poly. P-type poly is nothing but it will be negative ion followed by a hole, negative ion followed by a hole, negative ion followed by a hole. So this is a representation of p-type poly, that is P plus poly. Now we are going with. So this P plus poly is going to be on the SiO2 layer, and above below that one we are going with p-type substrate. Everything is going to remain same. Only what we have changed is nothing but simply the gate material is now replaced with P plus poly. So this is also N plus, this is also N plus. Now if you apply positive voltage, what happens for this diagram? If you apply positive voltage across the gate, at that time positive voltage is going to be repelling the holes. So holes are going to be moving near to silicon dioxide gate region. So they are moving in this direction. So they are moving now downwards. By that time the actual diagram is going to be looks like, it will be consisting of negative ions are going to be forming near the gate material, okay, and what you are applying is nothing but positive voltage. This positive voltage, even though you are applying, this negative ions is going to be stopping the effect of positive voltage. That is nothing but it is restricting the effect of positive voltage. Whenever it is restricting the effect of positive voltage, the actual effective positive voltage applied for channel formation is going to be very small. So you must apply more positive voltage to overcome that negative ions, effect. By that time, to get the same channel, we require a larger positive voltage if you use P plus gate poly, that is P plus poly gate. If you use, it requires more positive voltage compared to N plus polysilicon gate. So out of these four options, the highest positive value is nothing but 2.1. So the answer for this one is nothing but 2.1 volts, D. Thank you. So in general, a p-type substrate is paired with N plus gate to achieve a small positive threshold voltage, and N-type substrate is normally paired with P plus gate to achieve a small negative threshold voltage. Thank you.